most simple way
So
possible.
here we are going to talk about redox reaction and what is redox reaction? So redox reaction is a reaction where reduction and oxidation both are happening simultaneously. The examples are rusting of iron or decomposers decomposing any organic substance in nature, the tooth decay that generally happens if you don't brush your teeth in the evening time
No
before
videos.
going to sleep.
No videos, sir.
Yeah, it is video, it's on. So now, well, oxidation of glucose in mouth by microorganisms that causes acid formation results in cavity formation. How is this exactly happening? It is a redox reaction where the bacteria are decomposing the tooth enamel. Okay, so these are the examples. Since we are talking about chemistry, we are not going to get into the biological aspect of it. The redox reaction with respect to oxidation state. Now we are starting with this. Oxidation state is the technical thing that you need to know. Oxidation state is the degree of charge that a substance has. Now it could be sodium. Sodium, see, basically it's a valency. It's group 1, group 2. Basically, here I have shown you all the valencies, but the thing that you actually need to understand is the oxidation state can be understood in combined state and uncombined state. Combined form means like H2O, like hydrogen is there with oxygen. So it is in a combined state. In a combined form, you have to follow the oxidation state. Now, this oxidation state is applicable for group 1 substances, group 2 substances, group 7, hydrogen and oxygen are common everywhere. So group 1, as its valency says, that is its oxidation state. So plus 1, group 2 is plus 2, group 7 is going to be minus 1, hydrogen is plus 1 and oxygen is going to be minus 2. These are its valency, general valency. But here we don't have any other thing to be like means we are not considering any other element apart of this. See, like sulfur is not a part over here, so you'll have to calculate the other thing which are not present over here. For uncombined form, the oxidation state is 0. Like H2 hydrogen is not combined with any other element, the oxidation state is 0. Sodium is not combined with any element, so it is having oxidation state as 0. Similar thing for chlorine as well, oxidation state as 0 when they are in uncombined form. Some examples I have given, like here copper oxide is there, it's in a combined form. Oxygen is going to have -2 oxidation state, copper is going to have +2 oxidation state, hydrogen is going to have 0 oxidation state since it is not combined with anyone. So finally what's going to happen during the reaction, hydrogen being more reactive is going to grab that oxygen from there and H2O is going to get formed. Now hydrogen is in combined form and hydrogen's oxidation state is +1 and oxygen's oxidation state is -2, and
Minus two.
copper has become 0 because it is an uncombined state. So now in terms of oxidation state, what is oxidation? Oxidation is increase in oxidation state. Now here if you see hydrogen's original oxidation state was 0, but now that has been transformed to +1. Is that an increase? Yes, that's an increase. So
Increase.
increase in oxidation state implies oxidation. Similarly, over here, copper you had which was having oxidation state of +2, but now it has become 0. So this implies reduction because it was +2, now it has become 0. There's a reduction, decrease in oxidation state. So these are the only things that you need to understand. So just to summarize, oxidation is increase in oxidation state, reduction is decrease in oxidation state. Then a few examples I have given, you can have a look by pausing it later. Let's proceed ahead. This is the only thing that you need to understand with respect to oxidation state, the first concept of a redox reaction. Okay, on the other hand, if you also want to understand how do you calculate the oxidation state, one very good example is the sulfuric acid, which is made by H2SO4. Now sulfur is the thing whose oxidation state is unknown, and hence I have written it as X. Now hydrogen is what? +1. Oxygen is what oxidation state? -2.
Minus two.
So you just need to multiply, because is there any overall charge on H2SO4? No. So we find this can give you an equation which is like this. 2 into +1 plus, why this +1? Because hydrogen is 2 times, no? And sulfur is 1 time plus X. So you just make this equation and evaluate the value of X. Simple. So in that way you can calculate oxidation state of any other unknown substance. Okay, KMnO4, K2Cr2. You must have seen that KMnO4, potassium manganate 7. What is that 7 that comes? That is manganese oxidation state. Transition elements have varying oxidation states. Let's proceed ahead. Here we are on the second aspect of redox reaction, where we are trying to understand redox reaction with respect to transfer of electron. Now, whenever a chemical reaction is happening, electrons are getting transferred from one point to other point. Oxidation is loss of electron and reduction is gain of electron. So it can be identified, it can be memorized in a very simple way by following oil rig. So here aluminum is there, and aluminum has become aluminium 3 plus. How is that possible? See, aluminum over here, it is a neutral state. It has same number of protons, same number of electrons. Whereas here, see, metals always have a tendency of forming positive ions. Non-metals always, like here chlorine, I have given example. Non-metals always have a tendency of forming negative ions. Okay, so over here, aluminum, it's very clear that aluminum is going to always form positive ion. What exactly is going to happen in this case? Over here, it has same number of protons, same number of electrons, but during the reaction, electrons can go and come. Over here, what has happened? The electrons have gone because metals have a tendency of giving electron, and here it has given away 3 electron. So if electron has gone, there are more number of protons. So by how much the difference is there? Plus 3 is the difference. The number of protons and electrons are differing by 3. So metals are always going to be positive, and that's how you write it. So aluminium loses 3 electron and hence becomes 3 plus charge. See, protons don't participate in reaction. So similarly, we find that non-metals have a tendency of accepting electron. And even if they lose electron, only they are going to give away their extra electrons. Like over here, chlorine is, I have mentioned as Cl minus. That indicates that already chlorine has extra electron. Is chlorine going to give its own electron? Never. Okay, so what's going to happen? It's going to just give its extra electron, and then you'll be getting chlorine atom. And you know that when two chlorine atoms combine together, it results in the making up of chlorine molecule. Okay, so this reaction. So over here we find the Cl minus has lost electrons. So loss of electron is oxidation. Oxidation is loss. So here we find it like that. Sodium Na plus, it's already positive ion. So this is having more protons and lesser electron. So electron can go and come, so it can gain electron and can nullify the effect. And here you see the second reaction, it has nullified the effect and it has become sodium, so it has accepted electron. So you have to think logically to make a half equation
So,
always. And
so over here, so they have more electrons, right? For the Cl minus.
for Cl minus has extra electrons, yeah, more
So
electrons, and
then
that's why they
it
were
needs to
minus.
so it needs to gain a proton.
And proton you can't gain in a chemical
Exactly.
reaction,
So the,
so it has to only it has to lose its electron in order to make the reaction move forward. Okay, so it has lost that, and that losing thing I have shown here, and hence I have mentioned that that electron, that person has lost electron, and that is why it is oxidation. Similarly here, it has gained electron, sodium has gained electron, Rig, reduction is gain, and that's how it is represented. Now then, so here only these two points you need to understand and create a perfect half equation. Now we are here on the last part of the redox reaction, where redox reaction is identified with respect to reaction with oxygen. Oxidation means gain of oxygen. Okay, one more thing I would like to add over here, that it is also loss of hydrogen. Gain of oxygen or loss of hydrogen is called as oxidation. What is reduction? Loss of oxygen or gain of hydrogen is called as reduction. Over here we are going to identify with one example, copper oxide. Copper oxide, oxygen is going to go away. Over here we find copper is devoid of oxygen. What's going to happen? So copper oxide has lost, and hence I have written reduced, and hydrogen has gained oxygen, and hence I am terming it as that it has oxidized and formed water in the process. So here I have written the same thing. You can have a look. And so over here we can say reducing agent, oxidizing agent. Let's understand what's this oxidizing agent and reducing agent. Oxidizing agent, which is also called as an oxidant, these are substances that oxidize others and they reduce themselves. The two examples that you have to remember from the examination's perspective are KMnO4 and K2Cr2O7, potassium manganate 7 and potassium dichromate 6. What exactly happens? You have to identify the color changes that happen. I have mentioned about the color changes here, talking about the first example of the oxidizing agent, which is KMnO4. The MnO4 minus, which is actually purple in color, it changes to colorless. The stable ion, I have mentioned that Mn2 plus is the stable ion. It's okay, but the color change is really important in this context. The second thing is K2Cr2O7. Cr2O7 2 minus, it changes its color from orange to green. So Cr2O7 2 minus is going to be Cr3 plus. Again, the color change is really important. So orange to green. The next thing that we have is the reducing agent. Now, what is reducing agent? Is also called as a reductant. These are the substances that reduces others and they oxidize themselves. What's the example? The only example that you have to remember is potassium iodide, and the color changes colorless because potassium belonging to group 1. So group 1 metals are colorless in nature. So colorless to red brown liquid it is going to form. Just remember this. That is it that we need to understand. So here we have finished this redox reaction. Actually, after this chapter, we need to talk about another topic, which is electrolysis, which always goes in continuation. And here we are on electrolysis. Let's proceed with this. Let's proceed with this.
ये
और
चलो.
ओके ठीक है